Here's our Math 2 Chapter 11 review. This is from the end of the chapter in your book. We're actually doing the chapter review, which I start here at number 1. So we have this polynomial, and it's telling us we need to write it in standard form and then identify it based on its degree and number of terms. So the first thing we have to notice is the standard form. Standard form always has the largest degree first, so we would negative 9r squared. We have 4 and 7 are like terms, that makes 11r plus 3. This is to the squared, so we could call it a quadratic. And then it would be a trinomial because it has 3 terms. Our second one is 3 plus b to the third plus b squared. So we go b to the third plus b squared plus 3. It's to the third power, and then it's going to be a trinomial. You could also call this a cubic. Number 3, we're going to do 3 plus 8t squared is 8t squared plus 3. Again, it's a quadratic. And then it is a binomial because it's only 2 terms. Number 4, we're going to combine terms and write it in order. It's going to be 4n to the 5th. N to the third minus n to the third actually becomes 0. So we get 4n to the 5th plus n. It is a binomial. And we're going to say it's a 5th. It's to the 5th power. So it's a 5th degree is 5. Speaking of 5, number 5. We go 7x squared plus 8 plus 6x minus 7x squared. Our like terms get rid of the 7x squared minus 7x squared. So we'd say 6x plus 8. With an x there, we call it just linear, and it is a binomial. Our last one, number 6, is p to the third cubed to the third. Since it's a single term with no addition or subtraction, we call it a monomial. And when there's 2 different variables, they actually want you to combine the degrees, and so we'd say it's the 6th degree. But it's more important that you recognize that p to the third and q to the third, so they're each cubes, they're cubics by themselves. Number 7, we're now simplifying, and it wants us to write them in standard form. So we go 2v to the third minus v plus 8 plus negative v to the third plus v minus 3. So looking at my v to the thirds, I have 2 and a minus 1. So that leaves me with a v to the third. Looking at my v's, I have negative v plus v just becomes 0v. And my constants, I have 8 minus 3, which is just 5. So we'd say v to the third plus 5. Number 8 is 6s to the 4th plus 7s squared plus 7 plus 8s to the 4th minus 11s squared plus 9s. Now the first thing wrong with this problem is they used s as a variable, which looks like a 5. We'll ignore that fact and still go through it. So I'm looking at s to the 4th. I have the 6 and the 8. It gives me 14 of those. S squareds, I have 7 and negative 11, so that's minus 4s squared. I have a 9s, and then I have a 7. For number 9, we're going to do 4h to the third plus 3h plus 1 minus negative 5h to the third plus 6h minus 2. Now when you subtract with polynomials, I would suggest distributing out this negative. So I'm going to distribute out, and that's taking the negative and applying it to all of the terms on the inside. In doing that, it makes it addition, addition, subtraction, addition, and I change each of the signs. So now I take 4h to the third and 5h to the third gives me 9h to the third. 3h minus 6h is minus 3h, and 1 plus 2 is 3. For number 10, we have 8 z to the third minus 3z squared minus 7 minus z to the third minus z squared plus 9. So I'm going to distribute out the negative. I go positive, negative, positive, negative. Maybe I should write this again. I got negative z to the third plus z squared minus 9. So I have 8z to the third minus z to the third is 7z to the third. Minus 3z squared plus z squared gives me negative 2z squared. And then negative 7 and negative 9 is negative 16. For our next set, we're going to simplify the product, and so we're going to do some multiplication. We'll start with 11. We have 5k times 3 minus 4k. So this just goes back to distributive property. Be careful with distributive property. Make sure you multiply all terms as you should. And what I mean there is I'm paying attention really to the 5k minus 4k. That needs to become negative 20k squared. So 15k minus 20k squared. Number 12, we get 4m times 2m plus 9m squared minus 6. Distribute. I get 8m squared. I get 36m to the third, and then minus 24m. Now I notice this one's not written in that standard form, so I'm going to move the 36m cubed to the front, the 8m squared second, and the minus 24m. In fact, I forgot this one over here needs to be in standard form, so it should be negative 20k squared plus 15k. For 13, I'm going to do 6g to the second times g to the negative 8. We distribute. I get 6g to the third minus 48g squared. Number 14, 3d times 6d plus d squared. This one we have to pay attention to our exponents. I get 18d squared plus 3d to the third. We got to move the 3d to the third out in front. So it's 3d cubed plus 18d squared. 15, we're going to do 2n squared, 5n minus 9 plus 4n squared. Let's get negative 2n there. We'll distribute. Negative 10n to the third plus 18n squared, and then minus 8n to the fourth. We need to put this out in front. Next is our third power, and last plus 18n squared. Now you may be thinking, could I sort these first and then distribute? And yeah, that'd work perfectly fine, because the order that they're in now, even after you distribute, this one is the largest, it still needs to go first. The last one will kind of fit in this section before I go to a new page is number 16, and that was q times 11 plus 8q minus 2q squared. I could sort this one out first and make it negative 2q squared plus 8q plus 11, then distribute, and we get negative q to the third plus 8q squared plus 11q. Okay, next we're on to number 17. We need to find the GCF and then factor the polynomial. So for 17, we're going to start with 12p to the fourth plus 16p to the third plus 8p. So my common factors here, I can take out a 4 and a p from all of these. All of these are divisible by 4, and each term has a minimum of a p. So it leaves me with 3p cubed plus the 4p squared plus 2. Now, I can't factor this anymore. I've taken out the common factor. This is the GCF, so make sure if it's asked just for the GCF, you say it's 4p, but our product we're left with is right here. Number 18, we're going to go 3b to the fourth minus 9b squared plus 6b. All of the terms have at least a 3, and they all have at least a b. So that leaves me with b to the third minus 3b plus 2. And it's the same as the one before. This is our GCF, 3b, and that is what we factored out of. 19, we're going to go 45c to the fifth minus 63c to the third plus 27c. We look at common factors of those. Maybe I look at it first and I see, well, I can take out a 3c from all of them. Well, that's going to leave me with this, 15c to the fourth minus 21c plus 9. Now, you have to go back and make sure you got everything out because this is still divisible by 3. So I'm going to take out another 3, put it on the outside, leaves me with 5c to the fourth minus 7c squared plus 3. Now it's factored completely out, and I would write it as 9c times 5c to the fourth minus 7c squared plus 3. And we call it a greatest common factor. That's 9c. A factor of it is 3c, but the greatest common, again, is 9c. Let's go to 20. In 20, we have 4g squared plus 8g. I'm going to take out a 4g from each term. Leaves me with g plus 2. Common factor, greatest common factor was 4g, and then the rest is g plus 2. For 21, we have 3t to the fourth minus 6t to the third minus 9t plus 12. I can factor a 3 out of everything. We have t to the fourth minus 6t, 2t to the third minus 3t plus 4. So I can't factor out anything else. I don't have another t to go with. Let me write that a little bit cleaner. Our greatest common factor again was 3, and we're left with t to the fourth minus 2t to the third minus 3t plus 4. For 22, it's going to be 30h to the fifth minus 6h to the fourth minus 15h to the third. I can factor out a 6. Not 15. Can't factor out a 6. How about a 3 and an h to the third? Because h to the third is the minimum that all of them have. That's the smallest one we have. So I'm going to take a 10h squared minus 2h minus 5 is what it factors down to be. Now we could look at factoring this a little bit more, but for right now, we're going to leave that as it is. Greatest common factor is 3h cubed. Number 23 is an interesting problem because it tells us we have two numbers, p and q. And they have a GCF of 5. And it's saying, well, what if there was 6p and 6q? So let's do it this way. Let's treat it as if it was addition. They're not like terms, so I can't combine them. But there are our two terms, p and q. Now it's 6p and 6q. What's our GCF going to be? Well, we know already it's 5. What I can do with this is I could factor out a 6 from here. And that 6 out here is a common factor, because at the greatest we're not sure. So our GCF is going to have the 6 from this, and then what we originally had with p and q, which was 5. So our greatest common factor would be 30. If you need an example to that, let's think p and q were 5 and 10. 5 and 10 have a common factor of 5. If I do 6 times that, each of them, I then have 30 and 60. Well, 30 and 60 are going to have a GCF of 30, so it fits to what we were looking at. Moving on to number 24. We have w plus 1, w plus 12. I like to draw the box whenever we multiply, so we'll do w plus 1, w plus 12. We get a w squared, a w, 12w, and a 12. And for those looking at you going, what box are you talking about? Well, I set up each term as along the top or the side, and I multiply the row and the column to get the new value in the box. So w times w is w squared, 1 times w is w, 12 and w, and then 1 and 12. What's nice about this is most times we get like terms right here, so I'd say w squared plus 13w plus 12. Now, if you're on Team Foil and you want to use the FOIL method, that's perfectly fine. What you'll even notice is as you do the FOIL method, your terms are w squared plus w plus 12w plus 12, and then you just combine the like terms. I like this because it does keep things a little bit better organized, a little more organized, I should say, and we won't miss like terms as things get more complicated. This is a method we could go to each time, regardless of how big the polynomials get. Where FOIL, if you go beyond a 2 by 2, it can be easy to miss things. So here we are here, 25. We have 2s minus 3, 5s plus 4. I get 10s squared minus 15s, 8s, and minus 12. These combine to be 10s squared minus 7s minus 12. For 26, we have 3r minus 2 squared. This is not 9r squared minus 4. We have to go through the process of solving here. Do not try to take the shortcut and get it wrong. We get 9r squared, that's for sure. We know it's a 4, but we have this minus 6r and minus 6r, which give us 9r squared minus 12r plus 4. For 27, 6g plus 7, g minus 8, don't forget the negative down at the 8 here. So I have 6g squared, 7g, negative 48g, and minus 56. So I get 6g squared minus 41g minus 56. 28. 7q plus 2 times 3q plus 8. Why did I write g's? So it would be 21q squared, 6q, 56q, and 16. So we go 21q squared, 56 and 6 is 62q plus 16. 29. We go 4n to the third plus 5, 3n plus 5. So 4n to the third plus 5, 3n plus 5. I get 12n, be careful here, that's to the fourth, 15n, 20n to the third, and 25. Now in this case, these two are not like terms. I can't combine them, so I'm just going to write them all separately in the correct order. I get 12n to the fourth, next is 20n to the third, plus 15n plus 25. Now it's in descending order. They can't combine if they're not like terms, so I'll leave it as that. See if I can get some more crumpling paper noises. Almost enough. All right, we're on to number 30. T plus 9, t minus 3. Do t plus 9, another wonderful letter to use that's confused with a plus sign. And t minus 3, don't forget to bring the negative down for the minus 3. You don't want to forget that. We get t squared, 9t, negative 3t, and negative 27. So this becomes t squared plus 6t minus 27. Number 31 is 6c plus 5 squared. You are not under any circumstance, going to write that as 36c squared plus 25. We're going to go through the box method, check what we have. 36c squared plus 30c5, so our answer is 36c squared plus 60c plus 25. We're looking at 7h minus 3, 7h plus 3. Now this one has a shortcut we'll talk about when we get to the factoring problems, but we get that our top right corner and bottom left corner actually become opposites of one another, where I have the negative 21h and the positive 21h. These actually become 0, and it's 49h squared minus 9. When we get to factoring, starting in a few problems, that's what we call a difference of two squares, and it's a pattern we do start to recognize. The fact that it comes up in multiplication, well, we don't have to use it, but factoring is more the use we want to see. 33 is y minus 6, 3y plus 7. We get 3y squared minus 18y, 7y, and minus 42. Negative 18 and the 7 are going to be a negative 11y minus 42. Don't forget the 3y squared out in front. 34, we have 4a minus 7, 8a plus 3. We get 32a squared minus 56a, 12a, and negative 21. Negative 56, positive 12 is negative 44a minus 21 tacked on to the end. 35. We'll go 4b minus 3, 4b plus 3. This one's looking like a difference of two squares. If you understand the pattern, you're already hopefully predicting that this is going to be 16b squared minus 9, which we get here in the top corner, top left, bottom right. And then we notice we get negative 12b, positive 12b. Those become 0, 16b squared minus 9. For 36, we're given a rectangle, has dimensions of 3x plus 5 and x plus 7. Well, first of all, if we wanted to find the area, that's going to be x plus 7 times 3x plus 5. That's showing it as a product. Now, if we wanted to represent it as a polynomial, we're then going to go through and multiply. So x plus 7, 3x plus 5, we get 3x squared, 21x, 5x, and 35. So our area would also be represented as 3x squared plus 26x plus 35. Now to factoring. 37. I have g squared minus 5g plus minus 14. When I look at it without a coefficient in front, it's a lot different than what we'll get to on the later parts of these. But I'm just looking for what can I multiply to get negative 14 that's going to add to negative 5. Well, 7 times 2 gets me 14, but if I want a negative product, one of them has to be negative, one has to be positive. I want it to be a sum of negative 5. That shows the 7 should be bigger. So we'll go negative 7, positive 2. So we'd write this as g minus 7, g plus 2. We check. Negative 14 is what they multiply to. They add to negative 5. We're good. 38. We go 2n squared plus 3n minus 2. Now, there's a few different ways we could go through, and you have factoring strategies. Some of you like to use a diamond, even though it looks like an X method. There's something called the Berry method, which you can look up. But what we've talked about in class is we looked at multiplying the first and last term together. Gives you -4. And I wanted to add to the middle term 3. So what can I use to multiply to -4 that adds to 3? A negative product tells me one's positive, one's negative. If they add to 3, I'm going to use +4, -1. So then I use that to split my middle term into these two terms, and then it's what we call factor by grouping. I factor out of the first two terms a 2n, leaves me with n plus 2. I factor out of the second two terms a -1, leaves me with n plus 2. Now I take what they have in common, which is n plus 2, move that out in front, and then what's left over is my other factor, 2n minus 1. For 39, we have 6k squared minus 10kl plus 4l squared. I can factor out a 2 from all of these to start. Once that's out, I'm looking to multiply to 6, add to -5. So I'm going to use a -3, -2, because if I'm multiplying to a positive, it should be both positive, both negative, but I need to add to a negative. So tag the 2 along. It's going to be a 3k squared minus 3kl minus 2kl plus 2l squared. Now I have these two variables here. What this means is when I write out my final binomial, it's just going to be something k, something l as my terms. I'll keep factor by grouping, just following the process. I can take out a 3k from the first two terms. I get k minus l. I can take out a -2l from the other one, and that's k minus l. These match, so that comes out, k minus l. I'm left with 3k minus 2l as my other factor. Number 40, we have p squared plus 8p plus 12. So I'm looking to multiply to 12, adds to 8. Looking at that, I could do 6 and 2, so I could do p plus 6, p plus 2. 41, we have r squared plus 6r minus 40. I can look here and multiply to -40, add to 6. So multiplying, one's positive, one's negative in order to get a negative. I can look at 8 and 5 are not 6 apart. We could do 4 and 10. 4 and 10 would be 6 apart. I want the 10 to be bigger, the 4 is smaller, so I get a positive sum. So that's r minus 4, r plus 10. For 42, on a new page, we have 6m squared plus 25mn plus 11n squared. So I'm looking to multiply to 66, add to 25. If I'm thinking of the ways I could get 66, I could do 1 times 66. I could do 11 times 6. Those don't work. If I took half of 6 and made it 3, and then put the 2 over here, 3 times 22 is 66. Oh, those would add to 25. So I'll go 6m squared plus 22mn plus 3mn plus 11n squared. Now, I factor out the first two, a 2m, so leaves me with 3m plus 11n. On the second one, I'm going to factor out an n, leaves me a 3m plus 11n. So they both have a 3m plus 11n, leftovers 2m plus n. 43, we got t squared minus 13t minus 30. I'm looking to multiply to negative 30, add to negative 13. Well, negative 3, negative 10 looks like our winners. Ah, but wait a minute. That would be a positive 30. How about we do 2 and 15, and we make the 15 negative? So that's going to be t plus 2, t minus 15. And that's a good reason to check as we go through. I look here, I get negative 30, it adds to negative 13. So it does work. Caught myself there. 44, we go 2g squared minus 35g plus 17. I want to multiply to 2 times 17, which is 34. I want to add to negative 35. Anytime I look at it and the sum is 1 bigger than what I'm multiplying, it's usually that number times 1, but they're both negative. So we're going to go 2g squared minus 34g minus g plus 17. We can take out a 2g. That's g plus 17 left over. Take out a negative 1. G, oops, that should be a negative there. Now they match. So it's g minus 17, 2g minus 1. 45. We're doing 3x squared plus 3x minus 6. I can factor out a 3. Leaves me with x squared plus x minus 2. Now multiply to negative 2, add to 1. Looks like I'm going to do x plus 2, x minus 1, because I get multiply negative 2, add to 1. Don't forget the 3 on the outside. 46, we have d squared minus 18d plus 45. Multiply to 45, add to negative 18. 45, I think 9 times 5, I think 3 times 15. Oh, if I did 3 and 15 as negatives, I would do d squared minus 3d minus 15d plus 45. Take out a d. Take out a negative 15. I'm left with d minus 3, d minus 15. 47, we get w squared minus 15w minus 54. For 54, we know is 9 times 6, but I need one to be positive, one to be negative, so that's not going to work. 18. What if we did 18 and 3? Made it negative 18, positive 3. W squared minus 18w plus 3w minus 54. We'll take out a w. We'll take out a 3. So we get w plus 3, w minus 18. Number 48, we have 2z 21 z squared minus 70z plus 49. You could start with trying to figure out the factors of whatever 21 times 49 is, but what would be easier is if we divided everything by 7. We get 3z squared minus 10z plus 7. So now with the 7 on the outside, we're actually looking to what multiplies to be 21 that adds to negative 10. Now the fact it's a positive product but a negative sum means they're both negative values. And negative 3, negative 7 would fit. So we do 3z squared minus 3z minus 7z plus 7. This becomes a 3z, z minus 1, minus 7, z minus 1, and then we get 7 times z minus 1, 3z minus 7. For number 49, we have negative 2h squared plus 4h plus 70. I'm going to factor out a negative 2 and get h squared minus 2h minus 35. I'm looking to multiply to negative 35, add to negative 2. Since it's a negative product, I know one's positive, one's negative. I want the 7 to be bigger than the 5, so I make it a negative 7, positive 5. So we go h squared minus 7h plus 5h minus 35. This is actually one where we don't have to factor by grouping, but while we're at it, it comes out to be negative 2 times h minus 7 times h plus 5. For number 50, we have x squared plus 21x plus 38. We're looking to multiply to 38. We add to 21. Well, 38, we have 1 and 38, but also 2 and 19. Those are going to combine to be 21, so we'll make it x plus 2, x plus 19. 51, we go 10v squared plus 11v minus 8. We're multiplying to negative 80. We're going to add to be 11. So we know it's going to be a negative and a positive. If we do 16 and 5, 16 and 5 would give us 80. So we go positive 16, negative 5. 10v squared minus 5v plus 16v minus 8. Take out a 5v. We get 2v minus 1. Take out an 8. We get 2v minus 1. So our factors are 2v minus 1 and 5v plus 8. For number 52, we have 5g squared plus 15g plus 10. I'm going to factor out a 5. Now I'm looking at multiply to 2, adds to 3, and I can see that it's g plus 2, g plus 1. And the last one, 53, we're looking at the expression 2x squared plus 15x plus 9, and we want to see if that's factorable. So we want to multiply to 18 and add to 15. Well, I don't have anything that comes to mind, so I can look at my factors of 18. I have 1 and 18, 2 and 9, 3 and 6, 4 doesn't go, 5 doesn't go, 6 gives me back to here. So these are my only factors. But none of these add to 15. So we're going to say no, we can't factor it yet. We see later on this year maybe we can. And the reason are no factors of 18 add to 15.